This is section 7.1 in your textbook, and it's on using factoring to simplify what are called rational expressions. We'll talk about what a rational expression is before we start. So using factoring that we learned in chapter 6 to simplify rational expressions. So a rational expression is a fraction with a polynomial as a numerator and or, so sometimes it's and, sometimes it's or, denominator. So the numerator and the denominator, the top and the bottom, can be polynomials. To simplify rational expressions, we take out any GCFs from the top or bottom and factor anything we can. So you look for GCFs first, and then you factor anything you can. A binomial, trinomial, four-term, whatever you can find that factors, you factor it. And this will allow us to divide out, one of my favorite things to do, divide out any common factors and simplify. So let's go over some examples. After I do a couple examples, you're more than welcome to pause the video and try it yourself. So example 1, and the directions are just going to say simplify. If I have 5x minus 5 over x to the third minus x squared. So I have a binomial on the top and a binomial on the bottom. I'm going to kind of look at what I have and see what I can do with it. So I have two terms on the top and two terms on the bottom. Sometimes it helps to put parentheses around them, which makes them a little bit easier to see. The top is one piece and the bottom is one piece. If I look at just the top, I have 5x minus 5. Right away the GCF should stand out of 5. If I take a 5 out, I'm left with x minus 1. So we looked for a GCF. Once I take out that GCF of 5, x minus 1 is just a binomial that cannot be factored, so we're just done. If we look at the bottom, if we look at just the bottom, we have x to the third minus x squared. You should notice that there's x squared in both of those terms. So again, we can take out a GCF of x squared, and that leaves us with x minus 1. So just looking for GCFs helps us simplify. We took a 5 out of the top, we're left with x minus 1. We took an x squared out of the bottom, and we're left with x minus 1. Now we have an x minus 1 on top as a factor, and an x minus 1 on the bottom as a factor. And since these are common factors, we can divide them out. X minus 1 over x minus 1 is just 1, and you can just cross them out. That leaves us with 5 over x squared, which is our simplified answer. So we divided out those common terms and got down to a single term expression, 5 over x squared. If you'd like to try that on your own, you can pause the video and try example 2. We have x to the 7th plus x to the 6th over 6x plus 6. So if you'd like to pause the video at this time and try this problem. What I recommend is starting with that fraction bar, just carrying it across so you have somewhere to put the top and somewhere to put the bottom. Then we're going to look for those GCFs. Between x to the 7th and x to the 6th, there's a GCF of x to the 6th, and that leaves us with x plus 1. If we look on the bottom, there's a GCF of 6, and that also leaves us with x plus 1. We have a common factor on the top and the bottom of x plus 1. We divide those off. That gives us x to the 6th over 6 as our simplified answer. So similar to example 1. Alright, let's try a couple more. This is example 3. We have x squared plus 8x plus 7. It's a trinomial divided by x squared minus 4x minus 5, another trinomial. So here you should notice right away that we have a trinomial on the top and a trinomial on the bottom. We're going to try to factor those trinomials into back-to-back binomials, just like we learned in chapter 6. First thing we do is look for a GCF between all three terms, and I do not see one. We notice that the leading coefficient is 1, which makes this very easy to factor. You don't have to write anything down but the answer. You're going to think of two numbers that multiply to positive 7 and add to positive 8, which is 1 and 7. So your answers are x plus 1, x plus 7. You want to start to be able to do that all in your head without even making your table. When you notice that the leading coefficient is 1, you think of two numbers that multiply to 7, add to 8, write out your answer. Same thing down here, there's no GCF. Leading coefficient is 1. I want to think of two numbers that multiply to negative 5 and add to negative 4. That would be negative 5 and positive 1. And you can write them in either order, but the 5 has to be negative and the 1 has to be positive in order to add to negative 4. So you might not be there yet, but you will eventually be able to factor these without hesitation. So from here, you notice you have an x plus 1 on top and an x plus 1 on the bottom, and they can divide off. That leaves you with x plus 7 on the top over x minus 5 on the bottom. You can leave them in parentheses if you like, but you technically no longer need the parentheses. Alright, let's try another one. Example 4. X squared plus 5x plus 6 divided by x squared minus x minus 6. I would suggest pausing the video and trying this one on your own.